Good afternoon, everyone, and welcome to our MSBA Applied Project presentation. We are Team A5, and as a part of our Applied Project, we have partnered with Sound Credit Union, and we would love to talk about how, through this project, we help Sound make data-driven decisions. I'm Shruti Kinjalkar with my team members, Devin, Dakota, Peter, Gavin, and Brenda. Our primary contact throughout this project has been Jennifer Reed, VP at Sound, and she has been immensely helpful in facilitating the completion of our project deliverables. Next slide, please. Who is Sound? Sound Credit Union is a local, not-for-profit credit union founded in the 1940s. Currently in its 80th year of operation and dedicated towards the financial well-being of Washington's communities. Sound Credit Union has 28 branch locations that are spread out from Everett in the north to Olympia in the south across 4 Puget Sound counties. Next slide, please. Sound had identified areas of opportunity that we were asked to look into. Sound had observed greater success in suburban locations such as Gig Harbor and relatively less success in urban locations such as Seattle. Sound was eager to identify these qualitative and quantitative factors that make a brand successful, that is, more profitable. And they wanted a data-driven approach when deciding what to improve about their current branches and what new locations have the highest possibility of cultivating a successful branch. Next slide, please. The primary goal of this project was to create a model of success that can be applied to existing and future branches. In order to do this, we were required to determine the characteristics and attributes that constitute to a successful branch. This was accomplished by analyzing current branch performance metrics across 28 branches. This project has placed emphasis on both successful and low-performing branches to help predict which market to deploy Sound's next branch in. Sound Credit Union has some low-performing branches, but isn't sure about how can they help these branches. The model developed can also be applied to these low-performing branches to understand areas of improvement. Next, Dakota will talk about our project roadmap.
Thank you, Shruti. So starting off this project, we met with various teams at Sound Credit Union to understand the scope of our project. We met with the marketing, BI, and executive teams. And when meeting with these teams, we were able to gather large amounts of data from various aspects of the credit union to get a better understanding of the scope of our problem. Next slide, please. This slide shows just how much data we were given to look for to give you guys a better understanding of how much we analyzed. The orange data shows the intrinsic values such as transactions, loans, and deposits. The blue text indicates the extrinsic values such as demographics, income per capita, and median household income. And finally, the green is our KPI total profit. On the right, you can see how much data we started with to how much data we ended up with, over 80 data points to just under 20. Next, I'll be talking about our data processing. First, we started off with our descriptive analytics to see what happened and what was going on with the data and what we could do about it. And to do this, we looked at various dashboards and correlations between the data points in Tableau. We identified profitability as a primary indicator of a successful or unsuccessful branch, and then we categorized the branches as either successful or unsuccessful. Next, we did our diagnostic analytics, and this is when we tried to wrap our heads around why everything was happening. This analysis takes a deeper look into the data to understand the causes of these events and the behaviors. We also drilled down on demographic data to identify more correlations between the points and profitability. Next, I'll be talking about our predictive and prescriptive analytics. During the predictive analytics, we use mathematical modeling tools to generate predictions about various characteristics within our model. We initially used RStudio to perform a simple linear regression, which takes all the known data points and helps determine which ones have the highest predictive power. During this phase of our project, we realized in order to fulfill what was being asked of us, we have to split our model into two, and this is where we started an intrinsic and an extrinsic model. The intrinsic model focuses on finding ways we can improve current branches, and the extrinsic model is to assist the Sound team in making data-driven decisions about future branches. Finally, we moved into our prescriptive analytics And this is where we took a look at all the information we had gathered throughout the quarter and developed predictive models based on these. We used Azure Machine Learning to build out our model to better understand what recommendations we could make to sound. Next, I'll be passing it off to Brenda and Gavin, and they will go through the Azure models we've created and the dashboards for sound.
Thank you, Dakota. So I'm switching screens now to show the demo for the intrinsic model. So as Dakota mentioned, we built our intrinsic predictive model on Azure Machine Learning Studio. And the way that we're planning to deliver this to Sound Credit Union is via this Excel template that has an Azure Machine Learning Studio plugin. And a couple things to note on here. So these columns C through I are all of the predictors or the variables that we narrowed down to. This scored labels column is the predictive total profitability. And this performance column buckets each one of these total profitability values into different categories. So we have low, mid, and high. So the way that we envision that Sound would use this template is by identifying a low performing branch. So let's take row 5, for example. And they would set a new goal for one of these variables. So it could be deposits, loan balance, or transactions. Just taking transactions as an example, we can set a new goal of 100 million, which is highlighted here. So keeping everything else the same, but changing transactions, we now have a predicted total profitability that's within the mid performance range, whereas before it was within the low performance range. So now I'm going to pass it over to Gavin, who's going to talk about the extrinsic model and the dashboards.
Thanks, Brenda. I am going to share my screen and show something that's pretty similar to what Brenda was showing as far as the format goes. This is our extrinsic model. So really the purpose of this is to be able to identify potential places that Sound Credit Union can go to maybe build a successful branch. So we have kind of, as Dakota talked about, we had about 80 variables up front, and then we kind of wheedled them down to these variables right here. Total population, population density, incomes, values of homes, how many financial institutions are in like a 1 mile radius of that area, how many bank deposits are in that area, and then the demographics breaking down by age. So what Sound Credit Union can do utilizing this model that we've built through Azure Machine Learning is they can plug in all this information that is generally available in census type data. It's available to the public. And then it would spit out, it's blocked out here for privacy reasons. But what it does is it will spit out a scored label like you saw on Brenda's. And it will give us a mid, low, or high range of that being a potential spot where Sound Credit Union could possibly expand to. So this is the extrinsic model. What we've also built out though are some dashboards, dashboards that can be used to kind of as a cheat sheet, something that they can use to be able to quickly navigate to see what a branch, maybe their intrinsic variables, like Brenda was saying, their deposits, their transactions, their total profit, but then how it maps up against their extrinsic variables that I showed, their total population, their income, their home values, and whatnot. So this is, again, it's blocked out, unfortunately, but for private reasons, but this is kind of how it's broken down. You have your intrinsic variables up top and then your extrinsic variables down below, and you can kind of see the correlations between those. And then they have the filter options, kind of like I was saying earlier, how they can kind of dive into it a little bit deeper. The other and final dashboard passing off is just like the extrinsic variable, but just a little bit more appealing to the eye. You can see that all the variables are there, but just kind of as a quick snapshot. So this allows Sound Credit Union to be able to really go in and dive in. If they want to go into the top tier branches, they can filter the top tier branches and see what their median income, their median house value, populations and whatnot. And they can also do that vice versa with the lower ones, because you don't want to go to a place that possibly that you have the availability to show that data that it's not a good place to go based off the data we have here. So I'm going to pass it off to Devin from here. He's going to kind of talk through kind of the opportunities for this and some recommendations. So over to you, Devin.
All right, thanks, Gavin. So next I'd like to talk about opportunities for improvement and really areas that the credit union could focus on going forward. So first off, our model is only inclusive of 4 years and approximately 150 rows of data. All of 2020's data is inclusive of the coronavirus pandemic, and so that must be appreciated. Through our journey, we also discovered that the data was not centralized in a common repository. Some of the extrinsic variables, we were unable to locate them, specifically the demographic data, and therefore we had to extrapolate growth rates to derive values or independent variable values. On the intrinsic side, we discovered in 2019 the credit union operated 2 core systems, and net income was not branch allocated for a 6-month period. Currently, our model accounts for net income annualized and allocated by branch. Lastly, and probably most importantly, we believe our model is not perfect, and there's no substitution for domain knowledge and years of experience. Specifically, a location could be earmarked that meets ideal demographics and for bank deposits, but through the knowledge or trade knowledge, they might understand that the market is oversaturated or even has poor site accessibility. Next slide, please. Moving into recommendations, we'd like to recommend that the credit union continue to take a more data-focused approach when making decisions in the future. Highly correlated variables for our databases, dashboard displays, and even machine learning models could all be warehoused in a single point on the credit union's network for real-time update. We believe this would be a big area of opportunity for the credit union when making future business decisions, and even could be utilized by all tiers of management. We also recommend that the credit union continue to strive and understand their market position through diagnostic and descriptive analytics. For example, as Gavin noted, through a very quick query, we can quickly understand credit union sweet spots. In an attempt to understand sweet spots, we quickly highlighted the extrinsic sweet spots for high performers and even that of low performers. In the extrinsic table, rather, in the upper right portion of this slide, we're able to see that high-performing branches have a median household income in the $60,000 range, which is about 10% greater than that of lower-tier branches. Conversely, we can see that bank deposits are about 55% less in higher-tier markets than that of lower-tier markets. Median home values are about 20% greater in the high-performing areas than that of lower-performing areas. We believe this is all very valuable information that could be considered when making future business decisions. We also wanted to test the accuracy of the model, and we demonstrated this in both cases. Intrinsically, specific levers could be pulled to understand how significant of an impact it would have on current branch performance. As Brenda demonstrated, increasing branch deposits or transactions while keeping other variables consistent can positively impact branch performance. Also, it's important to note feature weights and which factors would have the most impact on this performance. In the intrinsic table to the right of this slide, transactions, deposits, and loan balances have the most impact on branch profitability and can be used to exploit lower performers to increase future branch performance. Extrinsically, sound branches were bucketed into categories to help understand how a future site may correlate to actual net income. As Gavin noted in his analysis, we have modeled a few future locations and ranked them based upon a scored labeling system compared against branch net income and the branch scorecard, which is a method of scaling or understanding branch performance with internal to the credit union. As you can see, there are 3 locations that we have potentially identified, all of them kept anonymous for privacy purposes, but you can see that some score well and others do not score nearly as well. And again, as I noted, our model is not perfect, and really domain knowledge must be applied when making any future strategic level decision. And finally, in summary, we wanted to highlight that we started with over 80 data points and narrowed them down to 17 across a 4-year period. Our analysis focused on the key performance indicator, profitability, or net income. We created dashboard displays for easy visualization purposes, as well as created 2 prescriptive models to help predict future performance and strategic level decisions. Next slide. And at this time, this concludes our presentation. We thank you for your time and open the floor to any questions you might have.
Well, hello everyone. As MSBA students at the University of Washington, Tacoma, we are delighted that you have joined us for our Metropolitan Appliance Showcase presentation. I am Andrew Phillips, and I am honored to be joined by Eugene Lee, Subhavar Darajan, and Jing Zhang. Before we get started, we would like to thank the staff at Metropolitan Appliance and the MSBA faculty for all of your support this past year. We would not have yielded the same amount of success without all of your efforts, so thank you. Just to give you a bit of background on Metropolitan, they are a locally owned and operated retail supply store that sells and installs high-end appliances throughout the Puget Sound region. The company employs around 35 people in a variety of roles and is located in Seattle's SoDo neighborhood. We signed a contract last June where we developed our initial scope for our project. We worked together with Metropolitan Appliance President Aaron Friedman to determine a scope that would bring value to the company. Metropolitan prides itself on incredible customer service and high-end products, so we wanted to develop a tool that complemented that. We'll discuss all 4 phases of our project, including the predictive modeling tool and sentiment analysis. This is a high-level overview of our project this year, but it was basically broken down into 4 main parts: descriptive, diagnostic, predictive, and cognitive analytics. We will explain all of these in more detail, but it is important to note that each phase built off the one before it. For example, we could not have drilled down our diagnostic analysis without first conducting the descriptive analysis. My point is that a phase would not have been successful if things had come together in a positive way with the phase that preceded it. We built a Google survey form that was deployed to the sales team to evaluate customer interactions and better understand the customer base. The survey data, along with sales data provided by the company, were used to build descriptive and diagnostic analysis dashboards in Power BI. This provided the company with valuable key performance indicators regarding things like sales figures over time. Last quarter, we developed the predictive modeling tool in a programming language called R. In simple terms, the tool recommends products to the customer that complements other products in which they are already interested. Finally, this quarter, we developed the sentiment analysis tool in the Power BI program, which allowed us to glean information from online reviews. Let's start by discussing the descriptive analytics portion of our project. This phase was implemented to gain a better overall understanding of the salesperson to customer experience on the showroom. This was accomplished by measuring key performance indicators for profit, order volume, and margin, for example. Scorecards were provided within the Power BI dashboard to illustrate success over time. And in analytics, when we find a good story to tell through data, we drill it down to find out more about it. That way we can tell the best story possible. And that's exactly what happened within our diagnostic analytics phase of our project. We took the survey data along with the sales data and drilled down our descriptive analytics to discover more about the overall showroom experience. Now let's talk about the predictive modeling tool. In the simplest terms, we wanted to build a tool that recommends products to customers that complement the products they are already interested in, as I mentioned previously, which would ultimately boost sales and leave the sales staff and customers with a smiling face. This tool is based upon an algorithm called a priori, which is built on what are called associative rules. You can imagine how items in Metropolitan showroom, for example, dryers, washers, and dishwashers, could be used to build associative rules as well. And this leads us to the prescriptive analytics phase of our project, which is where the predictive modeling tool would be deployed. The thought process is that after deploying the tool, the sales staff can recommend products that complement other products the customer is interested in already. This happens live on the showroom floor, and if deployed efficiently and effectively with a good faith effort from the staff that we know we would receive based on previous experiences, the tool could be used to boost sales and better understand the customer base. Finally, let's talk about the sentiment analysis tool that we developed this quarter. Sentiment analysis is often used by businesses to detect sentiment and social data, gauge brand reputation, and understand customers. For metropolitan sentiment analysis, real customer feedback was scraped from the web. Given in raw, unstructured text, the reviews were extracted to determine the most important phrases that would give a strong indication of whether a customer had a positive or negative experience. Let's jump over the Power BI and begin our technical demonstration. We'll start by discussing the descriptive analytics portion of the project that includes our initial dashboard with KPIs. As you can see, we have built a dynamic dashboard with dates that range from January of 2019 until October of 2020. We highlight the total profit, total order volume, and average margin for the company, and these can be manipulated by the top ribbon to change from year to date to month or quarter to date, for example. We discovered several interesting findings in our initial analysis. For example, LG was the top performing brand, especially for the 30 to 45-year-old age group. Now, for our diagnostic analyses, we drilled down our descriptive analytic phase for additional data discovery. We evaluated areas such as employee performance evaluation, order closing days, and cost per brand. Our findings showed that 80% of orders were closed within 1 month. As one can see here. When considering cost per brand, General Electric generated many more quotes than Sub-Zero. We thought this might have something to do with price. The scatter plot shows us that more quotes are generated for lower price items. Breaking down the analysis even further, Sub-Zero is the highest price brand in the store, with GE and LG having the lowest prices. Thus, we could conclude that the more budget-friendly brands were generating more sales than the premium brands. I will now turn it over to Jing, who will discuss the predictive and cognitive analytic phases of our project. Jing?
Yes, thank you, Andrew. So I'm going to open my Power BI. Can you guys see my Power BI right now?
Yes.
Okay. And thanks, everyone. My name is Jim, and I'm going to show you what we have done for the predictive and cognitive phases. So in the predictive phase, the data we used contains over 6,000 transactions and about 30 different product categories. And since we used a priori algorithm to mine the relationship among these categories, the relationship will be represented as these rules. And as you can see here, we have generated 13 rules based on some predefined criteria. For example, the support value for each selected rule should be larger than 0.01, which means at least 1% of these transactions are affected by each rule. And when we look at these rules, we find out while the relationship between dryer and washer is obvious, there are some other rules worth noting. For example, the first rule, we can read it as if dishwasher and under-counter refrigeration are purchased together, then 57% of the time, the non-OTR microwave will be purchased. And compared to a random selection, the chance of customers buying this kind of microwave will increase by 8 times if customers had already bought those 2 products. And therefore, this rule is particularly efficient in finding the non-OTR microwave. And similarly, the second rule is efficient in finding electric range due to the high lift ratio. We can also visualize these rules using a network graph, and with the collection and arrow indicating the relationship. And the scatter plot here can help us to understand each row's strength measured from 3 different criteria. And as mentioned earlier, this tool can help the leadership team decide which products can be displayed together, which products can be offered in post-transaction coupons or recommended during the shopping. So, okay, next, let's look at the cognitive phase. In this phase, our team has utilized text analytics provided by Azure Cognitive Service to uncover customer sentiment and opinions towards Metropolitan Appliance. And we can choose either platform to analyze the reviews, include reviews and comparing the difference to gain more insights. And this can help the leadership team to differentiate marketing strategies on the 2 different platforms. So let's take Yelp as an example. We know that both customers and business owners value the Yelp rating because the rating score is a good indicator of how well the business performs in the customer's mind, right? And as we can see, the current average rating for Metropolitan Appliance is 4.69 out of 5, which is much higher than its competitors. Not only that, there is also an inspiring uptrend of rating since 2014. However, the rating couldn't tell how customers really feel about the product and service, meaning it is possible that 2 customers rate the same but have different sentiment, which will fall into 4 different categories: neutral, negative, positive, mixed. Yeah, but in our case, there is no neutral reviews. While neutral and positive, negative are very straightforward. The mixed review means there is a combination of negative sentences and positive sentences in this review, which identified by the algorithm. And for Metropolitan Appliance, the majority of the reviews are mixed, and about 32% are purely positive reviews, which is pretty good. However, it's worth to notice that the proportion of positive reviews has decreased for the last 5 years, although the average rating has increased during the same time. And besides, we can also find a similar situation from Google review. So this is very interesting, as we're wondering if it is because the customers nowadays become more critical, or if the company has missed something. So I would suggest to have a further investigation to find out afterwards. While in addition to the sentiment of a review, it is more beneficial to also understand how customers feel about specific attributes such as delivery, installation, price, sales stuff, service, etc. So our team used opinion mining technique, which will return the subject opinion and corresponding sentiment. Here, say we are interested in delivery, so we can enter this keyword to extract this opinion with the number of times the relevant subject has been mentioned. Yeah, you can see. So here, the table on the right shows more granular information related to the subject. And if we select the comment here, sorry, I'll just click out. Okay, so if we select comment here, we can see all the subjects being mentioned and its corresponding opinions. And as you can see, using this tool, the sales team can quickly identify which areas are performing well versus needs to be improved. And if we can get customers' reviews of the competitors, it can help to differentiate our service and products so that the company can provide better customer experience and remain competitive in the home appliance market. Thank you. And I will transit to Andrew, and he will talk about the recommendations.
Thank you so much, Jean. We'll pull our slides back up. We will continue. So let's talk about how Metropolitan can best move forward. For the descriptive analysis, let's continue monitoring overall key performance indicators, being wary of the phases of COVID impacting order volume. Pay close attention to inventory and sales to optimize staffing and warehousing needs. And since these areas provide opportunities for improvement, the Metropolitan staff should keep the upcoming cohort updated with the most current data. For the diagnostic analysis, continuously evaluate the drilled down analyses such as cost per brand and employee performance evaluations. Where there are opportunities for improvement, use the data as a guide to determine how to provide an optimized solution. For example, merit-based promotions and bonuses can be awarded to high-performing employees, whereas additional resources can be allocated to motivate and encourage those employees who might be struggling. For the predictive analysis, use the recommendation tool to recommend products that complement other products that the customers have already purchased to increase sales. Display the associated products together to facilitate and promote sales and serve customers with a better shopping experience. Create an incentive program to motivate sales staff to utilize the predictive modeling tool and store data for the upcoming cohorts. The tool's algorithm can be continuously retrained in the future as additional data are collected. These tasks will be completed by upcoming MSBA cohorts. The current prototype should be considered only the foundation for future analyses. And finally, for the cognitive analysis, track customer rating and the proportion of positive reviews from online review providers like Yelp and Google to understand customer perception and how it changes over time. Use opinion mining to determine how each specific areas are performing. And for areas that need improvement, additional resources can be apportioned to improve those areas and provide the best overall customer experience possible. The sentiment analysis should be used in ways that provide additional insight into how to optimize the company's showroom experience. For next steps, we recommend implementing the prototype into the workflow if possible. If not, upcoming cohorts can help with that. Continue to utilize the sentiment analysis tool to gauge customer satisfaction over time. And finally, begin to think about what the company would like to accomplish with the upcoming cohort. This could include addressing questions concerning staffing, inventory, or warehousing needs. And with that, we can conclude our demonstration. We can't thank the staff of Metropolitan Appliance enough for all of your support throughout the past year. We know the upcoming cohort will have the same amazing experience that we had. We feel that by building the predictive modeling tool and the sentiment analysis, along with our earlier data discoveries, that we have laid the foundation for future cohorts to address other Metropolitan needs. Thank you for your time, and are there any questions?
Hello, everyone, and welcome to the presentation from Team A7. Our work this year has been with the Tacoma Fire Department, working with their CARES program. CARES stands for Community Assistance Referral and Education Services. And what the CARES program seeks to do is to go beyond traditional emergency services to provide non-emergency services to 911 callers who need assistance but might not need the help of fire or ambulance services. So my name is Stephen Hahn. My pronouns are they, them, theirs, and I have the pleasure of introducing the rest of the team and telling you a little bit about the journey that we've been on with the Tacoma Fire Department, as well as the proposed solution that we will be providing to them this year. So here's the rest of our team. From left to right, we have Belle DeBella, Amy Geisen, Genevieve Christensen, and Julie Neerman. And before we go too further, I just want to touch on what the mission of our entire project was. So the CARES program has been experiencing an increase in the number of calls that they are serving for the communities of Tacoma, Fife, and Fircrest. And what we have partnered with them to do is to create a prototype predictive model that will enable the fire department to make decisions on future operations in order to meet the changing needs of the community with a focus on behavioral health, including substance misuse. A lot of the increase in the call volumes that the TFD is seeing right now is related to behavioral health and other non-emergency services. And like so many departments and businesses right now, they're under resource constraints. Our job was to help them figure out how to best allocate their services so that they could serve as many community members as possible with maximum impact. So I'm going to turn it over to Jen to talk through the journey that we've been on and keep us going.
Thank you, Stephen. Over the last year, we have been on a journey with Tacoma Fire Department. In our summer term of 2020, we began with onboarding, going through the administrative process of school, as well as working with our client and obtaining the foundational knowledge that we would need in order to proceed with this project. As fall term commenced, we started to take on that data acquisition. So looking at mirroring databases and creating the database schema that we would be using later on. Winter term, we started to look at data discovery and analyzing the historical trends, as well as starting to look at the narratives, which has then brought us to spring term. So where we're at right now, we have been very much focused on data analytics, looking at text classification, the predictive model, creating paginated reports, as well as dashboards to be used by our client. Our project has not been without its complexities. You can see our three main areas being HIPAA compliance, our execution environment, as well as our learning sequence. So HIPAA compliance coupled with the execution environment has been one of the things that we have been very thoughtful about, making sure that we're safeguarding that information and containing it in the appropriate compliant ways. We also have had multiple systems of record that we've been working with spanning years of information and truly a vast amount of information. Further, right now we're actually learning about our text mining, which we have come to learn in our project has really been the heart of what we needed to do. So it's been a lot of information and a lot of applied information very quickly. We would also find that having some subject matter expertise would be beneficial as well to our project. So I'm going to turn it over to Julie, who's going to talk about our text classification project, as well as our regression model for predicting call volumes. Julie?
Thank you, Jen. So I'm Julie Neerman, and my pronouns are she, her, and hers. The first step in setting up our model is to create a new variable that represents whether an incident is behavioral health or not. Abel started us off by querying 1,000 random narratives from TFD's emergency response software called ImageTrend. We then had 3 people review and manually class those incidents, taking the majority rule to decide whether a call was behavioral health or not. We reviewed the narratives looking for keywords like suicidal or any substance misuse. This random classified set became the training and test set for our model. Using Microsoft Azure machine learning and existing Python libraries, we brought in the incident narratives from ImageTrend, did some pre-processing, cleaned the text to remove extra spaces, any numeric and special characters, and taking into consideration any acronyms. Then we determined the term frequency inverse document frequency, or TF-IDF score, in which those scores were then used in a gradient boosting classification model to classify whether a call was behavioral health or not. Next slide, please. To give you a better idea of the extensive vocabulary of the narrative, Amy put together this word cloud of the cleaned text that the model is attempting to sift through and identify the specific vocabulary that is most commonly associated with the behavioral health calls. Next slide, please. The current prototype for the text classification resulted in 88% accuracy in the testing set. Our test set was classed with 12% behavioral health, while our manually classed training set was actually at 24% behavioral health. This means the current prototype is underestimating, and one of the ways we recommend further improvements be made during future efforts. The resulting classified label is now available to be used for further modeling and analysis. Next slide, please. The next part of our prototype model forecasts the volume of behavioral health calls per day. We did this by appending the previously discussed classifier back into the dataset and aggregating by day. This was done for all calls in ImageTrend through mid-May 2021. The current proof of concept model is using a time series model called ARIMA from the forecast package in R, where we found that there was stationarity without trend in the data. The model uses autoregressive order of 2, 1 drift, and 1 moving average. Looking at a 100-day forecast of behavioral health calls, the model has a 95% prediction interval range of 3 to 20 calls per day. And that for non-behavioral health calls is 46 to 101 calls per day. This is another area that we think can be improved in the future efforts by taking a longer range of data and test for seasonality by month, and to do this per specific zip code or unit jurisdiction for the Tacoma Fire Department. This can then be used to support resource allocation for when and where Tacoma Fire Department resources are most often requested. Next, Abel will walk through our data acquisition and paginated reports.
Thank you, Julie. So our client, Tacoma Fire Department, generously provided their operational data, for us to analyze it and come up with a working solution, like Julie mentioned, classifying incidents as behavioral health related or not, and assign appropriate resources to operational divisions. As the data contains personal identifier information and also medical information, we need to treat the data with higher sensitivity and care about the data. So we find a way to locate the data from the on-prem system to the cloud environment, which is in Azure environment. So we had to write some SQL Server Integration Service ETL tools to copy the SQL Server database from the on-prem system to the cloud again. So due to the nature of the complexity and also the network and the VPN issues, we were not able to use UDOP provided data science virtual machines. So we had to use our own laptops to connect to the Azure provided managed data services. So to analyze the data in a low and higher level of detail, we have used Microsoft Power BI standard and paginated reports. We have also generated operational level reports, or maybe you can call it application, to help navigate old and legacy system records that was stored in the data warehouse. As two of the legacy systems, Siren and AMS, do not provide a visual interface, we need to come up with this solution to help ourselves and TFD staff to navigate through these records. And With this report, it's like TFD staff can navigate into individual incident records and medical information for a given patient without having the skills, to write standard SQL statements. And due to the nature of the data, we cannot walk you through every single record and patient information, but the solution that we provided can help you look for a given patient or incident by searching, the patient full name, or maybe names begins with or ends with. Also, if a name contains a given character, you can also search for a patient record by gender, zip code, and social security number. So the search capability, we extended it into searching for the narration part. So if we are looking for a given narration tied together with incidents, we can search for like suicides between this date to this date. And we can search for multiple words or a single words. With that, the report will take you to a list of incidents that has got the patient information, and you can even drill down into the patient narration. You can drill down into the patient's vital information. If there are any medications or procedures performed for that incident, you can also navigate to that level of detail and look into specific incidents. With the next, I will let Amy to speak into the higher level of the data analysis we did. Amy?
All right, well, thank you, Abel. So I'm going to go through some of the dashboards that we created for our client. These dashboards were created using Power BI, and we also integrated the text classification that we did to determine if a call is behavioral health or not into these dashboards. They can be used at a high level by, leadership in the Tacoma Fire Department to get an idea of the overall resources that are being expended, as well as used in other applications. So the first dashboard view that we're providing is just a high-level overview of the activity that the Tacoma Fire Department sees and the calls that they respond to. You can see that we're showing that the Tacoma Fire Department has quite a high volume of calls. They've responded to a total of approximately 79,000 incidents since January of 2020 and served about 43,000 patients in that time. The next dashboard view that we're providing is some information about the frequency and the location data around the calls that are being received. You can see that this map is showing there are quite a few hotspots in the Tacoma area where the Tacoma Fire Department is receiving a large volume of calls that generally correlates to the downtown Tacoma area. And then we're also providing a overview of the unit types that are being dispatched these calls. The next dashboard provides an overview of some of the behavioral health indicators for the calls that are being received. So we have some information about the possible opioid overdose reported, the reasons for that, indicators for if the caller is homeless or not, which can be very important in determining some of these types of calls. And then some information about if it's a possible overdose or opioid related incident. And then on the final dashboard view, we have just a quick overview of the demographics of the calls that are coming in. So we have information about the race, gender, and age group of each of the callers, and then some information about the top 5 medications that are administered on some of these calls. And again, all of these dashboard views are available with, filtered based on if they are determined to be behavioral health or not, and can provide a lot of future insight for the Tacoma Fire Department. And with that, I'm going to turn it back over to Julie, who's going to talk about future possibilities.
Thank you, Amy. With the prototype models and analysis discussed, we are excited about the future possibilities of these models, with some improvements to both the text classification and predicted call volume model methods, and having a professional review a larger sample set to train the model. This would improve the accuracy of the incident classification and ultimately better resource allocation decisions. We also note that we think that the classification types can be expanded on with either subset classifications of behavioral health, like general anxiety versus suicidal ideation, or adding new types of classification for those incidents involving the older communities. This would again support resources being distributed throughout the community more effectively. Next slide, please. And we want to thank the Tacoma Fire Department and the Center of Business Analytics at UW-Tacoma for their collaboration and the opportunity given to us to create this prototype. We know that the impact will benefit our community and potentially save lives. Thank you.
Hello everyone. Thank you for joining our Applied Projects presentation. For our Applied project, we had the honor of working with Schnitzer Steel Industries, which is based out of Tacoma, Washington. Our project champion is Adam Small, and our primary point of contact is Matt Stevens. To start off, my name is Kevin Bird, followed by...
I'm Morgan Bullock.
I'm Shweta Shankar.
I'm Sino Dodvand.
And I'm Wendy Du Bois.
For the agenda, we will cover who Schnitzer Steel is and what they do. Next, we will give a brief introduction of the project goals and deliverables. We will then move over to Power BI, where we will give a live presentation of the dashboards we have created. Lastly, we will cover our final findings and recommendations. What do you think happened to your first car after you got rid of it? It likely ended up at a metal processing facility to be shredded, melted, and turned into new products. Our MSBA team had the privilege of working with Schnitzer Steel's Tacoma's facility, who is a global leader in metal recycling industry. Since 1906, Schnitzer has been collecting, processing, and recycling raw scrap metal, both ferrous and non-ferrous, and providing that processed scrap metal to mills and foundries around the world. Schnitzer also has their own steel manufacturing facility where they transform some of the recycled scrap metal into finished steel products such as rebar, wire rod, and other specialty products. To begin, our team spent time on site with management to understand how the shredder operates and how material is processed through the yard. The shredder is capable of turning a vehicle into small metal chunks in a matter of seconds. That enormous power comes with an enormous amount of data, followed by a large amount of upkeep and maintenance. I will now pass it off to Wendy to cover the project introduction.
Thank you, Kevin. Our project centers around Schnitzer Steel's shredder mill, the heart of Schnitzer Steel. By using the data produced by the shredder, our team set out to create a set of Power BI dashboards. The dashboards will be used to monitor the production status of the shredder mill, generate reports and graphs, and the efficiency of the shredder operators themselves. Our project with Schnitzer Steel was completed in 4 phases: discover and plan, plan, analysis and design, develop, and deploy. In phase 1, discover and plan, we focused on understanding Schnitzer Steel's industry, market, and the organization itself to learn what opportunities there were for using data analytics to digitally transform their business. We initiated our project with them by first creating a project charter and project plan, and then conducting an industry and company analysis. With Porter's 5 competitive forces, we discovered the technological potential to increasing profit through the use of technology on operation and maintenance management of their recycling systems, especially with regards to the shredder's operations. As part of our strengths, weaknesses, opportunities, and threat analysis, also known as SWOT, we learned Schnitzer Steel is poised to take advantage of technological advancements, including optical recognition and the Internet of Things real-time data analytics. These would improve the overall processing and throughput of materials through the shredder, thereby increasing its profitability. Lastly, we used what we had found so far to document the project's scope. Ultimately, our goal is to develop proof of concept and prototype dashboards and early warning systems using the company's existing database to maximize shredder productivity and improve the downtime maintenance management. In phase 2, analysis, plan, and design, we turned our attention to the data analytics plan and process. This phase focused on the data itself by creating a data management plan and profiling document. We identified all aspects of data management, including how the data was collected, stored, secured, accessed, and how it would be ultimately delivered in its analyzed form to Schnitzer Steel. As part of creating the plan, we used Excel to learn more about the data's architecture and features, including approaches to cleaning the data. We documented our findings through a data dictionary, tables, and data flow diagrams. This part of the phase led to additional questions and clarifications about the data with Schnitzer Steel's SMEs. Next, we recommended data exploration using R and Tableau and using preliminary statistical models and visualizations to better understand the significant features and to uncover feature correlations. As part of this phase, we also explored different agile project management methodologies, including Scrum and Kanban. Our team ultimately used Kanban boards to support our project task processes. In phase 3, Develop, we concentrated on creating the solution itself. Because of the data exploration we had conducted in the prior phase, we were able to create a more easily accessed way of storing and retrieving the data via a SQL database. Once the SQL database was in place, our team used a combination of methods and tools such as R, Excel, and Power BI to explore additional statistical models for prediction. Using the results led to the creation of the dashboard prototypes. There will be more on these dashboards and reports in a few minutes. We were also able to present our initial prototypes to Schnitzer Steel's management team for their initial feedback. The last phase has been phase 4, Deploy. In this final phase, we have focused on finalizing the prototype, documenting its functionality for Schnitzer's use, providing a final summary of recommendations for the next phase of the project, and finally presenting the project itself to Schnitzer Steel's management team. By using Power BI, Schnitzer Steel was provided a set of prototype dashboards and reports that their management can use to monitor the shredder and their shredder operators. To use these dashboards, a guidance document was created to walk individuals through information such as how the data behind the visualizations has been transformed and how to do basic modifications to alert settings. The transformation plan includes not only a summary of the project as it stands, but recommendations for the next phase, including the adoption of additional tools, such as an anomaly detector offered as part of Microsoft Azure's AI tools, and strategies to increase profit by decreasing shredder downtime. The most exciting part of all 4 phases is everything culminating into the final prototype dashboard presentation to the Schnitzer Steel management team. All of the team's work throughout the phases is distilled into this final presentation and handoff, and the solution that will ultimately save valuable time and the tremendous potential to increase profits through the increasing shredder operation time. Throughout the 4 phases, we have used many different tools, including MySQL, R, Power BI, and Microsoft's Cognitive Services and Power Apps. Next, Shweta will provide a demonstration of the new Schnitzer Steel's Power BI report.
Thank you, Wendy. Let us look at the Power BI report we built with Schnitzer Steel. Please note that all the numbers are made up to protect the privacy. For a recycling industry, their productivity is heavily dependent on their operators' capability. So it is very important for Schnitzer Steel to monitor their operators' performance. We have various parameters such as mechanical availability, pounds per hour, speed losses, etc. to measure operators' performance. We have provided this data both in tabular format and in visual format. The tabular format helps to get the exact numbers, whereas the visual format will help in comparison. Not all the data you see here was readily available for us. We had to use some of the calculations in Power BI to get these numbers. We had to use calculated measures, we had to use calculated columns, and we had to use calculated tables. As you can see, we have provided various filters here. So the management can get the data they want just with the help of single click. They can filter with various operators, they can change dates, etc. The other important factor for Schnitzer Steel to monitor is the downtime. The reasons for the downtime, the operators who cause the downtime, and so on. So again, we have provided the same data in tabular format and visual format for management to get a high-level glimpse. So such reports we were able to create in Excel itself. we wanted to add additional capabilities with Power BI. So what we have created is similar to our time series chart here. We show how the shredder changed statuses over time in a single day. The other important parameter for Snitzer Steel to understand is the process variables. How the process variables vary with respect to time, with respect to status is very important to understand what is happening within the shredder itself. So we have plotted some of the important process variables with respect to status here, so Snitzer Steel can understand what happens to these process variables, for example, when there is a speed loss. The other type of chart we have created is plotting the process variables with respect to time and with respect to each other. So for example, using this chart, Snitzer Steel can understand how the process variables are changing with respect to time and how they change with respect to each other as well. This is just a beginning, and Snitzer Steel can implement such charts for any process variable they think is important in the future. My teammate Sina is going to continue with the Power BI demo.
Thank you, Shweta. So to utilize the Power BI reporting for shredders maintenance, we thought about using measures inside the Power BI to monitor certain values that we thought is going to be related to the later downtimes on the maintenance issues. For example, if we go to the maintenance report over here, you can see that for some of the process variables, like temperatures, we are counting the number of the times that they go above a certain desired range. Or for some other process variables, such as thermal capacity, that needs to be between a certain range. We are counting the number of the times they are in that range or above it separately. We're also measuring some simpler variables, such as the number of the speed losses that happen in the last operational day, or like the time frame that they can choose from the slicer. All these measures have the ability to become a gauge or a card in the dashboard that's finally get uploaded. And we can put alerts assigned to them through Power Apps flows. So every time that they get triggered, an alert or an email will be sent to the important management persons or the technicians. And to handle the size and the speed of access of the data, we have used the incremental refresh capability inside the Power BI. And the way it works is basically after the management is okay with the format of the reports, which we are giving them a manual on how to modify it and change it in the format they want without changing the data model, they can upload it and publish it to the Power BI online service. We have a snapshot of it right over here. When they are uploading their reports, they can decide how much of the historical data to keep and only refresh the newest data that comes into the client's SQL server daily. Therefore, the incremental refresh alongside with daily schedule refresh allows our client that every day that they come to work, the data from the previous day have been basically imported into the Power BI online service automatically. The reports and the visualizations get refreshed automatically. And if anyone has a subscription to these dashboards, an email having a snapshot of his dashboards will be sent to them on a daily basis. Now I will pass it to Morgan to go over summary and recommendations.
Thank you, Sina. So currently, there are no major issues, and Snitzer Steel has more opportunity to develop their data analytics for metal processing and recycling operations. In summary, our team was able to generate new dynamic reports and enhance Snitzer Steel's shredder performance tracking while also creating new opportunities for efficiency and metal shredding production. Our top 3 recommendations were to increase access to more data from previous years. Access to more data will enable them to learn more trends from the past and make better decisions about their future production. Next, we recommended to research strategies to gain access to near real-time data and use data streaming technologies to enhance their incremental refresh so that they can get data reports for immediate decisions. Lastly, we recommend to continue to evaluate data gathering strategies for tracking shredder maintenance and quality assurance for future maintenance dashboard development. This concludes our showcase presentation. Thank you for joining us and learning more about Schnitzer Steel and our applied project. We hope you'll join us for our poster session so we can answer any questions or comments. Thank you.